Hey, what's up, everybody? I'm having a few little, it's just technical glitches, but I wanted to make sure to get a video for you guys today. So we're going to solve polynomials, okay? But some higher order ones that I wanted to have you consider, okay? And I have to write these down. So okay, let's start with these two. So x cubed minus 1,000, you want to solve this. I'm having some glitches. This one, it's a struggle to factor. It's just more challenging. So you can just like go at this way, right? Add 1,000. When you take the cube root, what do you get? You get x equals 10. Okay? And it's explicitly 10, not 10 or negative 10, because this is an odd degree. So negative 10 times negative 10 times negative 10 is actually negative 1,000. So you don't have to worry about any of those other things, okay? So you see my little work. Now this one, you're going to want to factor, okay? So let's consider what factoring looks like for the bottom one, okay? So x to the fourth plus 11x squared minus 26 equals 0, all right? Now, what I always like to tell students, and factoring takes a comprehension of numbers, is you're interpreting this. So you need two numbers, because remember, we're going to start with the binomial form. All right, and these are going to both be x squareds, not x to the fourths. Or excuse me, instead of x. These are both going to be x squareds. Yes, it works. Okay. So you need two numbers that are going to go here and here. And we say, okay, what multiplies to 26? Okay. And then this is key. So do we want sum or difference? We want where their difference is 11. Okay, so two numbers, a times b equals 26. A minus b equals 11. Those are our objectives to the two numbers. Okay, we have a plus and we have a minus. That's what our binary is going to be here. So just do factors. What multiplies to be 26? Well, we've got 26 and 1, 13 and 2. Those are our only options, actually. But lo and behold, what is 13 minus 2? 11. So you put in 13 and 2. Okay? Are you with me? Or are you with me? I've got to erase a little bit of this. I'm sorry, I know, because it's useful. But it's still equal to 0. Okay, next phase, this cannot be factored any further because it's a positive. But can this? Now this actually is the difference of squares, but we don't have to necessarily factor it once we've done this because we can know, okay, x squared plus 13 equals 0, or x squared minus 2 equals 0. This one is going to end up with I, because when you square root it, you get root 13i. So x equals plus or minus square root 13 I being the square root of negative 1. This one over here, right, you get x squared equals 2, x equals plus or minus root 2. I know my handwriting got a little wompy there for a second. So sometimes you have to factor, and sometimes you can just go right for the answer, okay? But you're going to lose. So there were four in the quartic, and now, of course, I erased it, unlike my other stuff. Because in the quartic, you're going to have 4 solutions. Just 2 of them were imaginary. In the cubic, you're going to have the wrinkle, but it's not going to be anything but 10. So let's look at one more. Okay, that requires a lot of factoring. Okay, yeah, x to the fourth minus 144. Now, if you take a fourth root of this, it's going to get wonky, but you might recognize that this is 12 squared. So this is the difference of squares. So x to the fourth minus 12 squared is saying x squared squared. If you remember difference of squares, x squared plus 12, x squared minus 12. Now when you do these, just like the last time, you can get x equals plus or minus root 12. And over here, this is going to be x equals plus or minus root 12i. And plus or minus, those are 4 solutions because it's a quartic. It's got the degree 4. That's how that works. If you just try to solve this, you're not going to find them all. Okay? You're going to get the fourth root of 144, which is going to give you a singular answer. And it's going to give you, if you put it in a calculator, positive root 12. But that's not all the answers. And that's what happens when you end up on the complex plane. I know I wrote this fast, so take a gander. Just trying to get some problems done today. My technical difficulties are just that doing this takes 10 minutes. Doing the others takes far longer because my computer has too many videos on it. But that's a good thing, I think. All right. There are other problems. We'll leave them for tomorrow. Have a good one. Take care. Yeah, just a lot of repeat. Graphing polynomials is what I have to upload. We'll hopefully get that uploaded later today or tomorrow. All right. Have a good one. Adios. Adios. Oh, come on, computer. It's freezing on me.